In the last slide we talked a little bit about domain, and domain is numbers that get input into the function, so like your x values typically. I'm just going to talk a wee bit about range. So range is like your kind of output, so the answers that you get out of a function. That's typically denoted by y. So here's a completed square and its associated curve. Now, if I was to ask what is the range of this function, the range of the function is greater than or equal to 1. Because in terms of the y coordinates that this function can take, its minimum y value is 1. So if it's not 1, it's greater than 1, it can't take any y value less than that because its minimum turning point is at 1. Therefore the range of that function would be greater than or equal to 1. Now that holds as well if we think about the actual function, y equals x minus 2 all squared plus 1. The minimum value that could hold will the squared bit, the minimum value of that bit could hold 0, add on 1, and the minimum value it could have is 1. Okay, we're just going to have a quick look at inverse functions. So, for example, what is the inverse function of 3x plus 5? So, if we think about the inverse function is basically working backwards. So, to build this function up, we start with x times by 3, we get 3x. Add on 5 and we get 3x plus 5. So basically think about it as if we're undoing that function. So start with x, take 5 away, we get x minus 5. And instead of timesing by 3, we divide by 3, x minus 5 over 3. So the inverse function to 3x plus 5 is x minus 5 over 3. So I'm going to look at another one. And this time we'll say f of x equals 2x squared plus 1. I'm just going to bring in a wee bit of notation now. F to the minus 1x, that's basically asking me for the inverse function. That's the kind of notation that you're thinking about with that one. So again, let's build this function up. So x, the first thing that happens is we square it to get x squared. Then we double it to get 2x squared. And finally we add on 1 to get 2x squared plus 1. So again we start with x, but let's start to undo things. So undo plus 1, x minus 1. Then it's divide by 2, which will give me x minus 1 over 2. The opposite of taking the square is taking the square root. So my final answer to this one would be square root of x minus 1 over 2. And that then would be the inverse function to 2x squared plus 1. Now remember, if we graph these, there would be a line of symmetry which would be y equals x. The other thing to denote as well is for inverse functions, if f of x and g of x are inverse functions, then f of g of x is always going to be equal to x, and that's a connection that always holds. A quick explanation for that could be if I said that f of x was 2x plus 1, and I'm going to identify g of x, the inverse function. So, start with x for f of x, times it by 2 and I get 2x. Add on 1 and that's 2x plus 1. So let's undo that. So take away 1, x minus 1. Opposite of times 2 is divided by 2, x minus 1 over 2. So the inverse function to 2x plus 1 is x minus 1 over 2. So if I call this one f of x, 2x plus 1, and this one g of x, x minus 1 over 2, I'm going to see that f of g of x will be equal to x. So I'm going to try that just now. So f of g of x is going to be f of x minus 1 over 2. So the f function is whatever's in the bracket write it down, double it, and add on 1. So whatever's in the bracket, write it down, double it, add on 1. Those two cancel out, get x minus 1 plus 1, they two cancel out, and as you can see, I get an answer of x, and that's the connection for f of g of x when f of x and g of x are inverse functions.